Are we live? Okay. Well, hello everyone. Welcome to the EmTech MArch final juries. First of all, I must say we're very happy to be back at the lecture hall, even if we have a limited audience. It's really nice to be here after such a long time. And for those of you who are joining online, welcome as well. I'm Elif Erdine, Program Head of EmTech, and I'm joined by Milad Shokatbaksh, our Studio Master, and Michael Weinstock, our founder of EmTech. So just a few words as an introduction. EmTech, as some of you might know, is a postgraduate program that is open for MSc and MArch candidates. So it's a very mixed program. We have students from architecture, engineering, various backgrounds. And today we are here to give feedback and celebrate our MArch students. And I would like to actually thank them because they have been through very extraordinary times. They joined AA during September 2020, which was the middle of the lockdown, and they had to complete most of their studies completely online. And so they had a lot of perseverance, and thank you for that. As I said, we're very happy to be here, and we're also joined by an esteemed colleagues and friends of the EmTech, so we would like to introduce our jury members to you as well.
Yeah, we're very happy today that we'll be joined by Dr. Christian Derricks, who also will be our keynote lecturer this afternoon, 6 p.m. Be with us. It will be a very amazing lecture, we are all sure. Dr. Christian Derricks is a director at The Line in NEOM and has 20 years of experience of research and design in architecture, computation, has been in Super Studio, Woods Baguette, and now as a design director in Line. We're also joined by Eduardo Tobuzzi, design director from AK82, and Xavier de Casteria, that is going to be here in any moment, principal at Hassel Studio. We are also, if you guys have been following us, we have done a collaboration with Hassel Studio Pavilion outside of the Bedford Square, which is not here now anymore, called Reemerge, with the help of Hassel. We would like to thank them all, and thank you for joining us.
Yes, and just before we start, we have three MArch projects this afternoon, and they deal with research topics ranging from local material computation through to architecture, through to new modes of infrastructure. And so we will start now with our first thesis project, Jeffrey. Thank you.
Good afternoon all. My name is Jeffrey Babu. My topic is urban air mobility and infrastructure development and design. And my is group 2, so it's like singing a song individually, group song individually. So let's start. Think about little more than 100 years ago, a horse pulling a carriage was a mode of transport for many people worldwide. Because motorized vehicles became the norm of few short decades, different modes of transport were pushed aside by motorized vehicles. A new change is coming soon, that with the modern technologies and how they are, even with the aviation technologies coming up, and advanced technologies that came up, A new change is coming soon that will change how we think about aviation is the world of over again, and that is called urban air mobility, or is called UAM. The idea could lead on demand air taxis flying around large metropolitan cities in the near future. This will change the way we think about how we travel and how cities look. UAM says that this century will even more revolutionary than the last time. This new ability, and this new way of traveling could completely change the urban landscape and change our travel habits. The main importance of UAM is the infrastructure development for the landing and takeoff of these vehicles. NASA is one of the main agencies that taking part of in regulations and other of for UAM. Another agency that who working on regulations of UAM apart from NASA is ESA, European Aviation Safety and Agency. UAM is unavoidable not only because of remedy of growing concession, it is also because of another social factors such as advancement of technologies and also money invested in the huge money invested in the development of UAM, and it's in the development of vehicles of eVTOLs. As per the studies, more than 50% of people are likely to use UAM from initial stage. Because of limited study resources, I have filtered out small urban areas to focus on larger urban regions and urban air mobility. To do this, I have applied a population filtering select in urban regions where more than 1 million inhabitants and applied in population density filter excluding low density regions with less than 100 inhabitants per square mile. The remaining urban areas were indexed based on travel time, commute stress, and annual congestion cost. The architectural ambition is to design the need of architectural models and methods for analyzing and quantifying the prospective demand for urban air mobility as a complement to public transportation, as well as any potential consequence were defined and applied to the context of the City of London. The UAM can be simplified into three categories based on their operations: the aircraft developers and the manufacturers, the regulation authorities, and the operating organizations. We carefully studied the major aircrafts in the market. The maximum wingspan of an existing eVTOL is 14 meter, that is by the company Lilium. The average distance of an eVTOL could fly is 100 miles with an average speed of 120 miles per hour. The evolution of UAM is categorized by 2030 and 2050. The over initial period, AIB connectivity will be prioritized where requirements of vertiports or vertistops increase based on demands of trips. Projecting to 2050, urban mobility will be prioritized. The requirement of vertistops is increased based on the convenience. Vertiports are similar to that of helipads. These vertiports can be placed above buildings, above towers in available space. The hub of eVTOLs are called vertihubs. The configuration of vertiports are subject to the availability of spaces, especially in conjunction with the rooftop of buildings or above public roads. The UAM network is the connective network system that ensures fast and flawless aerial vehicular movement between origin, pickup, drop-off, and back to origin system. The hubs are the docking and servicing yard of the aircrafts. This is mainly because of the limitations of flying distance that an eVTOL could fly, that is 100 miles. From the phase 1, the evolutionary development of UAM network system over the years was not considering factor during the phase 1. This leads to a network development based on a generator of external Voronoi grid. This bottom-up approach has satisfactory featuring initial developments of integration of urban air mobility. Towards the phase 1 in the vision of 20, phase 2 in a vision of 2030. The verti-hub locations are classified based on top-down approach, ensuring most potential connectivity between vertiports in their route. The design of vertiports and their initial locations is need to be prioritized as a factor of more public element. It is understandable that verti-hubs might be operators infrastructure where vertiports are more of public interactive structure. The bottom-up approach, the site selection for the verti-tower configuration, vertiport prototype development and sprints were conducted. The London zones are classified into 3 zones by the TfL. Based on these classifications, major transportation hubs such as train stations, bus stations are marked. Among these locations, 4 locations, each zone is locations from each zone is selected through a clustering process, and the shuttle distance of AOV is calculated from each selected point. Also, we have compared the economical statistics products by TfL. Major transportation happens in outer zone of the city with 20% percentage of population.
Apologies.
Based on the analysis from the experiment, it is evident that the placement of verti-hubs at inner zones ensures maximum connectivity. In this bottom-up approach, the Liverpool Street Station is selected as a model location where based on several factors such as building, types, mixed occupancy styles, etc. The mobility and occupancy around the station was carefully studied. In 150-meter distance around, there are no potential unused land that can be used for installation of vertiport. The other potential vertiport locations are above roads with wider pathways. The shortest distance between the nearest business centers and modality were compared with the potential vertiport locations, and the best location is chosen using the short walk analysis. The vertiport has a core hydraulic shaft system that lifts down and up into the building so that the passengers could board directly into from the passage. These systems give the possibility of the building system much hassle-free and easy. It also ensures better safety for the passengers. In this experiment, third experiment, we have tried to analyze the development of vertiports above the roads. The height of the towers, number of shards, sunlight reflection, visual privacy are taken consideration during this experiment. By using wireless analytical and evaluation engine, selected the best predefined solution based on maximum sun exposure, maximum lifts or columns, maximum mean distance from the buildings, and minimum height.
Yeah, sorry. Could you slow down a bit, please?
Yeah.
You're out of breath already. You can't answer questions later if you keep going like this. So it's better for us if it's a bit slower so we can actually understand the content better. Thank you.
Sure, thank you. The sunlight analysis has conducted to ensure the better lighting on the roads. Actually, because since the road these buildings are covering the roads, the sunlight falling on the roads is need to be analyzed, and also the visual obstruction that happens to the nearby adjacent buildings is also calculated. This is to ensure the privacy of the surrounded buildings. The facade material system is developed such a way that the fins can be tilted to ensure better visual blocking and lighting into the building. The artificial trees have mosses that help stop pollutants like particulate matter and nitrogen oxides from the air. These trees looks like an almira and were integrated to the IoT technology that can send information about the environment around them and how well the trees and other devices are working. This, as per the calculation, this 50 meter square mosses fins can be compared to 275 trees in terms of cutting down population. The experiment is the fourth experiment insists to evaluate the evolutionary growth of UM and expected elevated network system. This elevated network system will be development new user experience and could carry new pedestrian supported travel modes and so. The evolutionary network system is a product of adaptive factors that supports the integration of vertiports. Here, vertiports around skyscrapers are removed as well. Between a centrality of pedestrian movement around the Liverpool station is also evaluated to avoid to a centrality of into a particular region. The connectivity between major attractions of the city, connectivity between the major attractions of the city is prioritized. Minimum distance between the vertiports, skyscrapers, and the skywalk are analyzed, and evolutionary pattern is predicted. Visual of how the elevated vertiport system will be integrated to the rooftop of the buildings. How the elevated pathways is a part of the city as a new user experience. Thank you.
Hello? Can you hear? Okay. I think you'll have to do a lot of back and forth in the presentation to be able to answer questions because it went so fast.
Sure.
So, because we, as your tutors have seen, we would like to perhaps ask the jury members for their comments and questions. Who would like to start? Maybe Christian? Would you like to give it a go?
Well, thank you very much. It was a dense presentation, very quickly presented, and I think there's a lot of background questions, of course, that I would have in order to understand some of the choices that you've taken or made. It's very interesting and, of course, very current topic, especially where I work now. It's one of the key mobility modes that are being implemented and legislated for. And hence, I've got a little bit of background from the mobility team that I work with on eVTOLs. But then it was really interesting that you started to combine air mobility with very traditional pedestrian network analysis, for example. So, there's been so much, and you went through it so fast. I just saw snippets almost, And then I saw, well, there's eVTOLs, and then there's things that you don't usually do. And then there's all of a sudden pedestrian or movement graph analysis measures. And then you have to kind of form a picture right now. But it's a very interesting project. And in fact, a project to be installed like this in a space like London is, of course, a new challenge, because where I'm sitting, of course, I'm not sitting in NEOM right now. I was meant to be in London with you, and unfortunately I couldn't make it because of the Omicron situation and having to go back and forth between countries. So where I'm meant to sit from, I'm sitting from Friday onwards again in NEOM. Clearly we're planning a new city where we can design in the constraints for air mobility. But London doesn't have that. And if I understood correctly from some of your speedy descriptions, was that you try to use roads, right? As predominantly roads as your heliports, that you said you're going to do some kind of analysis that looks at spaces above roads, the airspace above roads, and then use those airspaces above roads as heliports. Is that correct, roughly?
It's a vertiports connecting an elevated network that eventually people will, the moment will be elevator and different user experience will be developed for the future.
But sorry again. So did you want to use the airspace above roads for your vertiports? Was that the general idea, or was it also on top of buildings?
Yeah, on top of buildings. It's like initially the vertitowers are placed, and eventually vertiports are placed on rooftops, and the accessibility to the rooftops is limited. So there will be an elevated network, a connectivity, pedestrian connectivity system that connects between vertiports and more accessibility between the buildings as well.
Yeah. So it's an interesting discussion that we're having as well in NEOM about, can we put the vertiports or vertipads, I mean, you have different dimensions of these air mobility interchanges or hubs. So with one platform, with multiple platforms, with almost like airports themselves, with whole array of platforms, and where you also maintain and store them when they're not flying. So all of that is, of course, being questioned. And I don't know if you looked at some of the constraints that helipads themselves have. So helipads also have some constraints why they can't land in the middle of the city, for example, helicopters. So because of environmental constraints, obviously they generate a lot of downdraft and wind. They produce a lot of noise, which eVTOLs don't. Yeah, so that's a benefit on eVTOL compared to a helicopter, obviously. And they, if they're being used for commuting, as you propose as well, clearly they will also generate at some point some air congestion. So looking down at the congestion on the road is very nice, but once everybody actually starts doing that, we also have air congestion. So that then generates routing diagrams. So questions about routing, how do you actually create sort of the right of way in airspace if you have these different layers of movement in the air? So there's a lot of questions around that I find, that even not working at NEOM would come into mind, and I think nowadays there's a lot of companies having made some proof of concepts and even further developments on eVTOLs, like Lilium, Volocopter, and Elevate, of course, by Uber went out of business or was bought up. It was sold by Uber. So they also took the above road vertiport approach. I don't know if you're familiar with any of that. That's probably you studied all of those different developments in order to create your own version of that, right?
Actually, it's in a Uber Elevate. Actually, there's a company have made an accommodation regarding this, and most of the approachable things like the lack of spaces in the city where new infrastructure can be deployed. So the most available space is above roads, and there is rooftops. So it's mainly because of the lack of space.
That's right. So that's what Elevate already produced, and Volocopter and Lilium, they go in a different route. They go in the route of building almost like out of town or in the green or brownfield vertiports. They basically know that they can't land too close to buildings. So even landing on buildings depends on its surrounding, because of downdraft and noise, etc. So there's different constraints that these eVTOLs have if they're being used if they were to be used in cities, because that really hasn't happened much yet apart from some helicopters and helipads. So I'm just wondering, because you didn't mention some of those constraints, I at least not in that speedy description that you've given, so I couldn't quite pick it out yet. So I'm just wondering if you studied them, if that went into your dissertation as well or your thesis, that you have actually made some created some background research on that. So and collected the constraints that you need in order to place these vertiports. Is that in your thesis then?
Regarding the placing of vertiports in rooftops, again, no, I
I
didn't
just
get the
asked
question.
you if you looked at the background, if you done background research, literature research, if you talked with these companies who are actually designing vertiports as we speak, and they've actually built them already, yeah, and why they built them in certain locations, why not in others? There's certain constraints to that. Yeah, if you have looked into that and collected the constraints before you design your own vertiports.
There are many companies like Volocopter have and eHang started developing their own vertiports called skyports and all. Basically, the thing is like the development they have made is called not vertiports. Actually, they are developing vertihubs. Actually, vertihubs and vertiports are actually called different because of their it's mainly for their particular company, their service and their charging, and so that's how that's why we have zoned these vertihubs to inner London zones, whereas vertipads are should be connected to the other mobilities like should be connecting with all mobilities like even with tube stations and bus stops where people are traveling to. So that's how it should be the new vertiport system should be more practical only when it is deployed to more urban spaces. That's why the chance of taking an adaptability to the rooftops and above roads are taken into consideration.
Okay, so by the sounds of it, you've looked at these companies and their designs and their constraints. That's good. I have another question, which obviously quite quickly sprang to mind, as I mentioned already, before I then hand over, is that you use centrality measures in order to, and I didn't quite understand what you did with them. I saw the images and you mentioned them. Between pedestrian spaces and the inner city vertipads, and why did you use them? How did you relate or apply graph theoretical measures to the locations of vertipads? Could you explain again?
It's basically thinking that the pedestrian movement and the people movement will be elevated eventually, and it will be more accessibility. Even may it's more about a projection of 2050, or eventually the growth is developed, and it will be a more it's more than currently it is a requirement, and over the period it will be basically it's a part of a convenience. People feel like more convenient that can go to their roof and connect a like eVTOL to fly to wherever they want, rather than like getting down and searching for a vertiport. And
sure, but why do you need any kind of centrality measures for that? I mean, that's the whole point, isn't it? That if you fly, you don't have to follow any road network. You can just fly. So that's what I meant earlier with route planning. So once you actually have congestion in the air, once you actually have air congestion, then you might actually have to think about routing. Maybe some kind of measures, graph theoretical or network measures will come into play. But otherwise, why would you constrain, a graph, or a network needs a graph after all, and that graph has usually been constrained by physical space. And why do you need that kind of physical space network analysis for your vertiports or pads that sit on top of buildings, according to you? And because I could obviously see maybe you're talking about the impact of pedestrians on the street at the street level when they fly in, but they're really not meant to probably go via the building down into the public realm. I suppose your suggestion is that they fly in somewhere and then stay at higher levels and they don't go down to the street level. So there wouldn't be an impact so much down at street level, depending how much, of course, how many people and what the capacity is per vertipad and vertiport and vertihub, etc. But if you then, for example, said, well, there's going to be connections at height between the vertiports, would they really walk between them, or would there be like an access mapping from different buildings to a vertiport? I don't quite understand the measure.
Actually, the thing is like not only eVTOL is the developing technology. We can see that the network. I was trying to say the importance of rooftop network. Like now we have e-scooters and e-cycles, which is like people are not allowed to use the street as well, whereby even not in the bicycle pathways and all. So there should be a space where these vehicles as well have to be used, and these spaces have to be elevated for this new spaces have to be found for people their own movement and all. Not only that, actually, the elevator network it's more about if it is a peak time. We actually now we are in a situation like of we cannot predict the rate of COVID and all. We cannot predict where is people are congested to one particular point or not in the growth in the future. But even though if we in the current situations there are like peak times, people are like in a peak time they will be moving to one particular locations. So it is very important that will be very great that in that scenario more vertiports will be connected to each other to give the distribution of people can be connected or like.
Okay, maybe you can show the slide again of your measures and the ports. Elevated walkways connecting buildings to vertiports.
Yeah, I'll see. Yeah.
So that's why you looked at the connectivity on it. So locations or solutions, you call them?
The rendered images, you mean? No. This one?
So any of those? I mean, just also the one that you just then move forward one, I think about the, this one just described the connectivity and the catchments per ports. And I still don't quite understand if it's about the ground level or if it's some elevated walkways on top of buildings. And then you showed then the centrality measures, the next slide. I think.
Jeffrey, do you want to go to the next slide?
Yeah.
Or one slide, I don't quite remember. It was so fast that it was two back or one forward. I don't know. And then you showed there centrality measures. And you showed distances between vertiports.
Are all the blue bits, the blue dots vertiports or not now? Here.
Yeah, they are the vertiports.
Yeah, I still don't understand why you need to connect them though. I think you mentioned something when you're just speaking, that you said, was it scooters and electrical vehicles aren't allowed or something like that?
Yeah.
Do you see like another elevated level of people moving about in electrical vehicles on those walkways, or?
Yeah, this is something about a new user experience, like over the period, like when people are all like eVTOL is a like elevator network system, like we are taking away to a height already. So the network system that connects between these things, like even the buildings and that connects to the rooftops, and people eventually they may have access to the rooftops, and it's like more of a vertical movement elevating up all the pedestrian movement eventually.
But then they're connecting to other buildings as well at the same time, or not?
Yes.
Because that's way more important than connecting to another vertiport, I assume. If you want to connect to from a vertiport to other buildings around there, which are somehow you wouldn't have that network, would you? I would say. Would look different, I think, no?
It's connecting between networks. It's like it's an eventual growth. Like they can be connected to each other. Like the movement between these buildings, like they can. If, for example, one building is one vertiport and the other, it's connected with another vertiport. The connectivity connects to the rooftop of the buildings, and eventually it can be connected, access to from that building itself to that particular connected network.
I mean, maybe, Jeffrey, rather than explaining it, maybe let's just say that you really need to rethink about this connectivity network and the sensibility of the connections between the rooftops, and that's something to consider for your submission.
Okay.
Right?
Yeah, I think for me, what might help us, I think, understanding a bit more the concept is understanding your starting point. What is the pocket of users and the sort of the reasons why I identify myself as a potential customer of this service, right? Why would I use this, and how many of us you thought about while putting this research in place? So that would help us understanding more the connectivity, the intended use. The other aspect that I find interesting is about reusing the existing infrastructure of buildings and understanding how that will impact our designs in terms of a building. Can we actually repurpose a private building to allow for a portion of it, you know, to suffice your services? And the third aspect is actually how a building would evolve, having to comply with potential damages from, you know, sort of such equipments. Because obviously now our transport network is a 2D grid. This would extend in a 3D network. And does the building infrastructure, does it have to have, you know, do we need to rethink the envelopes of our building? Because I think you study a lot about the connection, but then you are interfacing with something that is existing. As Christian was mentioning, you know, one thing is to do it in a place that is about to be built, so you can think about all the necessary measures to avoid problems. But inserting this in London will have also an awful lot of more different complexity. So I thought that I found it interesting. I don't know if you thought about it.
Do you know the space that you need around a vertipad for different wind conditions? Because these vehicles, the eVTOLs, are really light, and they're being blown out quite quickly. So if you have a little gust of wind, so there's all sorts of security and safety measures and constraints are being considered for where you place them. So you don't sit next to a building, you've got a vertipad, and all of a sudden eVTOL comes in and slaps against the other side of the building. So you have to always have, so these considerations as well, where you build them, not just over the road, or what the wind channels are in relation to these vertipads. I mean, it's a really interesting topic, and it's great that you picked that up. But there's a lot of consideration, a lot of potential as well, you know, how that changes. In fact, like I said, the change of the network analysis is immense, yeah? So that you used old physical network analytical measures that effectively don't apply. So it's much more reasonable, effectively, in this context here, to use social network analysis rather than physical network analysis. Because like you just mentioned, the other juror, is that, you know, if I was a user and I don't have any physical constraints, of course, other than the vehicle and gravity and possibly air congestion, that's what I mentioned earlier. You fly somewhere not in order to get down to the street level, but you probably fly somewhere in order to stay within a building or a complex of buildings. Yeah, and that building or complex of buildings will have a different demographic or socioeconomic activity, whatever, you know, that's not the same as a street level. So all of a sudden you get probably a connectivity between locations that is more based on something less physical and something more, you know, social and economic. And that's a different network measures altogether.
Christian, Xavier, Eduardo, would you like to add something?
Yeah, that's fine. Sorry, and apologies, I was following the presentation in the cab here because I had a problem coming across town. I should have probably taken an eVTOL myself. But there's a big question. I'm going to kind of ask the question again, but maybe you've actually explained it in the beginning of the presentation, because I did miss that bit. Was, who is it really for, and where are you flying to? Was that explained, or did I miss that? Because I think that's a really, really important question. Like, what are you competing with? What other transport things are you competing with? Is it taxis, expensive taxis? Or is it something else? And where do they go to? And what distances do they go?
You don't need to answer to all the questions.
Yeah.
And also, like, how many people is it, right? Is it 4 people? Or is it 10 people? Or 15? Because these you know, the larger ones are coming now as well. You know, you have the small ones for 4 people, but the larger ones will be reality in about 5 years' time. So it's a really good thing to kind of really analyze, what are you competing with? What is it that you are doing better than an existing thing?
These are things to reflect back when you submit in 10 days' time. Thank you.
Thank you.
Thank you all.
Elif, just a question then.
Sure.
So what stage are we at here now in the?
We're at the final stage,
Yeah,
Christian.
final. So they're resubmitting. You mentioned resubmitting.
No, they're
When-
submitting their final dissertations next Friday by 1 p.m. in
Okay.
10 days' time.
Mhm.
Yeah. Yeah. Thank you.
So the recommendation you're giving right now, we're giving.
Yeah.
They have about 9 days to integrate that.
Yes. Exactly. Yeah.
Great, fantastic. So there were really light comments we gave you just now. Good.
Definitely. Yeah. Thank you. No, it's amazing. Thank you. That's great. Thanks, guys. So our next team is with us. Well, Nupur is physically with us, and she'll be joined by Puyan and Hongyu.
Online, yes. Hello all. Our team, as Alif mentioned, is me, Puyan, and Ongyu, and we're going to present our thesis dissertation, The Adaptive Continuous, and it's a video presentation, so I'll play it for you. Due to advancement in technology, there is an increase in online activity, as functions can be performed faster online and multiple functions can be performed at a particular time. This has led to a decrease in volume of people visiting physical spaces, causing underutilized or vacant spaces. This condition has been aggravated due to the pandemic. Increase in online retail and remote working are a consequence of increase in online activity. Online retail has risen from 13.5% in 2015 to 32% in 2020, and remote working has risen from 2.5% in 2001 to 6% in 2020. As a result, vacancy rates for offices have gone from 4.4% in 2017 to 6.5% in 2020. Vacancy rates for retails have also risen from 10.3% in 2019 to 14.1% in 2020. As a response to the challenges posed by contemporary lifestyle, there is an increasing need to accommodate for a variety of changing spatial and programmatic needs in the process of urban revitalization. Taking the context of the high streets in London, we have chosen the Oxford Street as our site of study. The high street is an important point of connectivity and a space for social cohesion and exchange. The Oxford Street is one of the most busiest and oldest high streets in the UK. The Oxford Street district contains a mix of functions. The following maps analyze the Oxford Street with regards to its functions. The map shows retails, residentials, commercial spaces, hotels, educational institutions, art galleries, parks, cafes, restaurants, casinos, and pubs and bars. Lately, it has been observed that there is a reduction in volume of passengers visiting the high street. The passenger index has reduced from 155 in 2016 to 78 in 2020. There has been an observed increase in vacancy in retail, offices, and housing. Retail vacancy has risen from 9.5 to 12%. Office vacancy has risen from 6.7 to 7.2%, and housing vacancy has risen from 6.8 to 8.4% from a span of 2017 to 2020. In order to protect the high street as a space for social cohesion from the challenges of contemporary lifestyle, we intend to develop a system of adaptability from an urban scale of redistributing functions to an architectural scale of enabling different spatial configurations to cater to the changing spatial and programmatic needs. The changes in spatial configurations are based on internal and external factors which affect the site at different time scales. Taking the specific case of the high street, we intend to develop a variety of interior and exterior spaces based on this system.
To gather and analyze the context of the site, Google Place API data has been extracted for further analysis on the activeness of each area. An automated system has been developed to interact with the user and make the design stage easier. The aim of the first experiment is to find the most suitable pathways that can be used to add new spaces. The site boundary is decided by using a walkability radius of 1/4 mile used by urban planning as the area which can be reached within a walkable distance. Analysis is performed for a street score and amenity score. A street score measures the number of the people that use a particular street. The street score gives an indication of the vibrancy of the streets. It helps to identify the most activated and the least activated area on the site using Google Places API data. Amenity hits measures the total number of people visiting a particular amenity on the site. The amenity hit helps to figure out which are the most and the least visited amenities in the Oxford Street. A multi-objective algorithm is used to find the least activated area with a good pedestrian comfort, with input of street network, amenities, building population statistics. The criteria for the experiment are activeness of the pathway, the length of the pathway, the width of the road, and solar hour. The final results show the pathway connecting the most activated area to the least activated area. The solution of the average fitness rank is chosen as it performed equally in all criteria. Taking 1/3 of the site as an input is to find the most suitable space for activity along the pathway. A multi-objective algorithm is made with the input of selected area from experiment 1. 3D model of the building on the site and pedestrian path. The criteria for this experiment are amount of sun exposure, view to outside, exposure to people, and distance from pathway to selected area. Since all the mentioned fitness criteria are equally important, the solution with average fitness criteria was selected for the next stage of the research. Analysis is performed on the result of experiment 2. A crowd simulation is made to understand the effect of the new spaces allocated on the site, and to understand if the distribution along the secondary network of the street is increasing. We observed that the distribution of people increased in the secondary road and number of movements in the main street relatively decreased. Experiment 3 takes the results of allocated spaces along the pathway to distribute the type of functions targeted, in this case social and cultural functions. A multi-objective algorithm is run with the input of selected spaces, probable location for the different functions on the site, and activeness of each function. The criteria of this experiment are relationship between similar function, relationship with the prominent function on the site such as retails, offices, and housing, and area with highest functionality. Since all the objectives of the experiments are equally important, the most suitable solution was selected as the individual with average fitness criteria. But since this part of the experiment can be run multiple times, some criterion can be prioritized over the others. Analysis is run on experiment tree using amenity hit and street hits, which helps to understand the effect of the distribution of movement based on the type of function. This analysis forms the Oxford Street District compared to similar analysis performed on successful case studies such as King's Cross and Wapping Wharf, which contains distribution, social, and cultural activities. The analysis is compared using a scoring system such as the amenity score. Amenity score measures the difference between demand and supply of the number of particular amenities in the area. If the amenity hit is positive, it's overutilized. If the amenity hit is negative, it's underutilized. The apt value of the amenity hit is close to 0. In order to facilitate different types of functions and requirements, a comprehensive study has been conducted. The analysis has environmental criteria, namely sun, view, sound, and a special criteria named as space openness and behavioral pattern. Space openness helps to vary the void spaces internally and externally of the space formations. Behavioral pattern can help to understand the focus of the space design. Understanding the environmental criteria of the internal space can help vary its effect as per requirement. These criteria can be varied depending on the importance given by the owner to satisfy functional requirements. The user interface is developed on the local scale. It's a loop system involving the requirements of the user's environmental performance and programmatic requirements. The user selects the units manually in the initial step. The units are presets derived from understanding the functional and special requirements of the type of functions to be addressed. The second step involves aggregation, which is automated. The units are aggregated for the selected space and all combinations of the preset units. The aggregation completes the space formations for the selected presets by the user. The third step involves analysis on the suggested preset, so the user can make modifications in the manual selection in order to generate a more suitable option. The importance of each criteria can be changed based on different conditions to propose an arrangement based on the requirements. The analysis is looped back into a system and the user can make manual changes in the presets informed by the decision.
Each space is divided into a three-dimensional grid. Each grid unit contains a module. The size of each module is 3.5 by 3.5 by 10.5 meters. Each module contains a movable slab system which helps to achieve the desired configuration. Each module of the system has two movable slabs held by steel cables whose movement is facilitated by a cam system which is attached to a motor. The system also contains a foldable partition system for needed privacy and to control the amount of light. The slab moves to 8 predefined stages with the help of the cam system. The predefined stages are derived from preset spatial formations, in turn derived from functional requirements. The upper and lower slabs have different movements controlled by different cam systems and a single motor. The cam system converts the rotational movements into linear movements which controls the length of the steel cable. The cam system consists of eccentric discs alternated with rectangular steel plates held together with steel rods, along which the steel cable moves. The shape of the discs at each point of the 8 points is in direct relation to the heights needed to be achieved by the presets. The shape of the disc is more elliptical and tangential to the cable at all points to allow for easy movement along the edge of the disc. The slab is made up of plywood supported by a steel frame. The slab also acts as a deployable staircase for the purpose of circulation. The 2D analysis shown on the right was integrated inside the interface to assure highest accessibility for the staircase. The partition system is based on an origami folding pattern. The foldable pattern is chosen such that it does not coincide with the other three sides of partitions when in folded state. Each side of the partition system can be lowered manually. The partition system helps to control light and privacy. The analysis on the right helps to understand where it can be placed correctly. The panels of the system are triangular in shape, hinged to each other. The material of the panel is aluminium frame and smart glass. The smart glass turns opaque when privacy is required. In order to prevent lateral movement, each aggregation of 4 units is given 2 steel columns. Each unit is also attached to the other unit with a simple interlocking steel rod. To draw additional support from the existing structure, the edge units are interlocked with steel plates protruding from both sides. The system was able to achieve flexibility in function by realizing different spatial configurations through use of real-time data. The experiments helped to distribute functions using data sets supporting actual use of functions and areas. This is a bottom-up approach which is dependent on actual use of existing functions and areas, unlike the typical top-down approach used by urban planners. The project is able to develop a combinatory system for space composition which combines manual and automated methods, creating a loop responding to the requirements of the user, internal requirements of function, and external factors which affect the site. The system responds to different timescales of change, namely seasonal and weekly, to cater to the needs of dynamic functional requirements. The project was also able to develop a working mechanism for the materials system chosen as an adaptable system. Although further investigation in the prototype can be beneficial to the research. Thank you.
Would maybe Xavier or Eduardo like to start, or? Okay.
I can start from the end, perhaps, because I think maybe it's the thing that touches me the most, and then perhaps leave it to Xavier and others to touch at the beginning, which I really would like to understand a bit more the connection between the large-scale study and the small. But in terms of structure, I found it interesting that you are implementing a system that is reconfigurable, although there are some profound sort of problems with it. I think personally I found some movable system lacking in terms of respecting the tolerances that we are used as an industry, and there are some principle of gravity that you are lacking there. So there are no columns in some areas to suspend your system, and to also prevent that the cabling system would be in place to allow the slab to move. So I think you need to kind of really rethink a little bit about the structural system, you know. But I was curious about what drove the exercise of reconfiguring the internal spacing. We had some experiments in a building in King's Cross with a large tech corporation, which, you know, where we actually looked at having different uses throughout the lifespan of the building, which we have achieved through the use of modular systems like CLT, but that kind of impacted the overall structure. We had to provide an infrastructural level to support that change, and those changes, you know, are not necessarily happening in a very short time. They require, you know, building size modifications, even in the HEV system and other infrastructural components. So I was wondering what drove your idea more than I was curious about that.
movements actually depend on seasonal variations. So there will be, so it doesn't change like on a daily basis, but it changes over a weekly basis when there is a difference in density of people, and also on like a seasonal basis where the requirements for summer for space openness would be much more different than in winter. So I mean that was the understanding for kind of exploring I think the system. The frequency of change is something that we were looking into.
Was it for a specific intended use, or it was, because to me it looked very general, but you know, what sort of, did you look at a specific typology of building, or?
I guess, sorry, that's a similar vein of thought to George, right? To George's?
Eduardo.
Sorry,
Ed, it's all right.
Okay. Sorry, and because I was wondering, just to pick up there, I suppose, maybe helps to question a little bit. So did you look into vacancies then around Oxford Street? Did you look into where vacancies occurred in what you mentioned are sort of connections that you created between least and most activated streets or locations around Oxford Street? Because is there any kind of correlation between, you know, we did these kind of exercises with my previous teams quite a lot. So understanding, you know, what type of need the community has and what type of land use and amenities are provided and which ones are missing based on lots of user analysis and research around the trends of the community and the offer and the supply of different retail and commercial spaces. So quite often what you're looking at, of course, is understanding what's already given and why, for example, are some amenities, some retail locations faltering, not failing. And I know, of course, Oxford Street is a bit particular because there's lots of rather large global franchise businesses on it, amongst some of the original stores as well, which have effectively been bought to turn them into kind of brands, you know, from of online retail marketplaces. So there are some peculiarities along Oxford Street itself, but you showed very nicely how you're going behind Oxford Street as well, so more of the catchment of Oxford Street. So there's a lot of nooks and crannies around Oxford Street and hidden streets and corners and places where you could have retail. And I'm just also wondering, like Ed was saying, what type of use do you dedicate to some of the locations that you found? And that use, how do you define that use, you know? Because you talked about least most activated, but what is the activation in these places and what do you complement those through? In order to create, of course, I mean, the point is in order to create, like you said, social cohesion in the beginning, yeah? So you mentioned social cohesion as one of your drivers, because you said with businesses closing and high streets becoming suffering, and all the decline in these rented or, you know, just generally spaces, decline of the use of those spaces, the question is, if you raise social cohesion saying that the streets are not activated or the places, that therefore community suffers, society suffers. So what type of land use do you instill that's missing that would create social cohesion and would activate those spaces? Because if you showed it once, you showed, you know, there's various levels of cinema and dance and this and that, you know, but I mean, is this actually complementary? Is it competing with the land uses that are just about still making it, you know? Then they would effectively compete with them and actually close more, yeah? So you have to ask yourself, what is in it?
I'm sure you guys will be able to answer this, but and I don't usually like to interfere, but the starting point of this project was the fact that due to COVID, there are underutilized spaces around Oxford Street. So that's how the thesis originated in the first place. And they actually started, maybe it didn't come across or they didn't show it in the right way, but the whole thesis started with an analysis of Oxford Street and which spaces are being underutilized and how they can be further utilized in the future. So maybe you guys want to expand on that, because obviously I don't want to explain what we have done. So could you maybe take over?
Thank you. Basically, we were looking at functions which were becoming more redundant, which is, and Oxford Street being the epitome of commercial activity. So we were looking at how retails and offices are shutting. And of course, like to answer your question in a way, they are being occupied, like we did look into the current spaces which exist, and they are being occupied by more temporary, like meanwhile spaces at this point. But so the secondary kind of network of Oxford Street has more of these food lanes and other other social functions, which basically the commuters, they go from the kind of retail, the shopping area to those back areas. And what we intended to do is basically to kind of bring that to the forefront. And what we did is actually take existing functions which do exist, like not provide any new kind of functions. But for example, if there are cafes, restaurants existing in that particular area on the Oxford Street, we would just redistribute similar functions in order to distribute the people equally in a way. And not have a kind of concentration of certain functions, like certain functions being occupied like a lot. So that's what we were intending to do.
So you do reinforce existing land users that are active?
Yes. And,
okay.
And also that in a way, because we are not kind of imposing new functions, we're also not dealing with the site consistently throughout, in a way that if there are particular functions strongly evident in an area of Oxford Street, we will enhance those functions, those social and cultural functions basically, and not kind of introduce new set of functions. So yeah, that's.
If you had, for example, I don't know, a cafe, yeah, for example, that you mentioned, so lots of cafes. So, but you can enhance such a pre-existing and predominant activation by complementary land use activation. Say, if you had, people maybe cycle through it, and you could have a bicycle repair shop, that is not competing with more cafes, but actually supports them, because, in a synergetic way, they also want to go to the bike repair shop and go to the cafe. So you actually create a synergy between different land uses that support each other. Do you know what I mean? So I'm just wondering, how refined effectively that that matching between the land uses was, and how you're trying to get people into those not, as you call it, so underutilized spaces, in order to utilize them more. I don't know if you have the same activation, but if you had complementary activation, then it creates like a little ecosystem of its own, where more people would be drawn into. So that's how I'm thinking about this. But it's by the way, it was quite impressive the amount of work that you guys had done. It was very rich, and it gives us lots to think and talk about, which is therefore, of course, a good side effect of it. I have to say, there was so much that you mentioned about the multi-objective optimization or algorithms that you used. Usually they used to be called multi-objective optimization. Was in fact usually for optimizing in the past, right? That's what they used. These algorithms were literally multi-criteria optimization. And then of course you had these other models that created trade-offs like Pareto and so on, so which still is a multi-criteria optimization algorithm. So how did you use them in this context? So because I didn't quite understand how you then used the multi-criteria optimization. It was quite a lot of information, so I didn't quite keep up with that.
Maybe I can take that one. Mm-hmm. So we use the algorithm, so on side of like a really simple kind of analysis to evaluate the spaces that we are trying to For example, in the experiment 2, we are trying to evaluate each spaces that we want to take. So like we have like 4 different criteria that like we are evaluating them constantly with a simple rules. Then like based on the different spaces that we are getting from the program, based on the different genes that we're receiving different spaces, we are also evaluating in each stages. So like at the end, we are hoping to find the spaces that like are performing well in all the categories. For example, we had the sun gain, we had the proximity to the path that we chose from experiment 1, and two more criteria. So like the idea was like to test the spaces that are available based on the situation that we assign to the model, to find a better option rather than like randomly select them, if that makes sense.
Yeah. Did you use an evolutionary type optimization model or more like an annealing type? Because that sounds more like an annealing algorithm than an evolutionary, which is very similar, but it's significantly different in terms of what you're trying to do. Do you know what type of algorithms you used?
I can tell you what program I used, if that helps.
Yeah, why not?
Yeah, I used Wallasey in Grasshopper. Which group does it go to? For my own knowledge.
I think if I recall well from Mohamed's presentation at Wallasey, and the projects I've seen there before, predominantly evolutionary algorithms. So they're kind of generative. They're not evolutionary programming. They're evolutionary but genetic algorithms, which basically generate a kind of outcome. So that's why I was also curious, So they're optimized towards something in a generative fashion. So crossover mutation, usually, as a basic model. I think it also used some Pareto or multi-criteria optimization. Again, it optimized towards something if you have multiple solutions. So the question is, how do you weigh in a Pareto front? The fronts within the optimization. So how do you actually say what's the dominating and the non-dominating criteria within the multiple criteria? And there's so many questions, effectively intricacies within it.
Yeah.
That of course then are interesting to know, how they were weighted and how you basically didn't generate anything, but what is it that you generate solutions for, that you select from, that the fitness function is described for, So you mentioned earlier sort of locations that are better performing for an infill function, yeah. But therefore, by the sounds of it, you didn't generate a physical outcome of any sort, but you must have generated sort of profiles of places, or what did you select from?
Yes, I'm not sure if I'm understanding properly, but yeah, like there was a set of solution that we were testing from each building in different heights, in different corner of it, to evaluate all these conditions that they have to find the appropriate.
So you did generate something in the locations.
Yes. So like in the presentation, if you look, there are like a small orange boxes.
Okay.
So those are our test objects.
Configurations, yeah.
Yeah. So like we were running the analysis on it.
I'm sorry, I'm just jumping in here because Puyan, the questions that Christian is posing are extremely important, and it shows that you guys need to properly present your experiment. We have been through multiple seminars talking about this, and the way that you set up the experiment for someone who wants to understand your project is extremely important. Otherwise, it will be seen as some arbitrary random generation of options. But I know that you guys haven't been doing this, and this is a very important point that was brought up, that you need to make sure you make it clarified. You clarify this in your submission and dissertation, because this is a big bunch of the project, and you use this tool significantly in multiple stages. And if you don't explain it properly, then it will be understood as some random generation of options, you know.
If it helps, one quick thing about that, because you're trying to normalize, trying to get from the peak areas and trying to redistribute it and normalize. So one aspect I think it's important to clarify is also how you challenge the norm of bias. So, if people goes to a cafe, if the cafe is popular, there might be also a reason why that is popular, and just renormalizing it and trying to redivert people somewhere else might not necessarily work. So I think that the aspect of bias is also important to understand. You might have done the exercise, but if you did, just it'd be good to explain it.
Just quick some reflections from my side. I think your presentation started really, really well. It was really clear, and I was really enjoying it. But then it did get a little bit confusing, and then it got quite confusing when you then jumped from your urban analysis to the more architectural part. Then I really liked the architectural part again. So it was a bit up and down, I think, your presentation. And one thing I'm still can't get my head around is I think I saw this project like months ago as well in the beginning. And I think I'm going to make the same comment. It's slightly similar to what Christian said. Is Oxford Street is not your standard high street, right? So it behaves quite differently, I think, than other normal high streets. The one I live near, Walthamstow High Street, is your standard kind of more suburban style, well, outer London, let's say, high street, where there is a massive issue of shops that are not running anymore, they're empty. People don't know what to do with it anymore, right? And you're trying to come up with an architectural solution for that. And I would love to kind of see you really tackle that more to a real situation, because I think you kind of go very quickly from your urban analysis and then you jump into the architectural one. I don't really see that connection too well. Because I would love to see how you tackle a normal high street and then really on the high street itself, not in the back streets. Because all the applications that you found was actually on the side streets and all that. And I'm actually quite interested if the high street itself, how do you tackle that? Because that's the real issue. And maybe not in Oxford Street. Maybe just slightly different because, you have indeed a Nike store that doesn't actually need to sell a single item. It doesn't matter what it sells. It just needs to be there, right? But other high streets, that does matter, right? So that's my first thing. Second thing, I quite like the architectural proposal. It's actually quite relevant in this new world. It's quite relevant if I see for our own firm as well, we just moved into new offices, it's too big. You want to rent parts out, we want to do different things, but they actually want to be much more flexible with spaces now. And they're like little, Cedric Price's fun palaces that you've made, right? Which is quite fun. Interesting enough, I think the technology itself is there. It exists. Look at companies like Stage 1, Tate Towers, that do all these stages or opening of Olympics. That technology is there. It exists. You don't invent anything. What I'm more interested in is like, how does it connect with your facade? How does it connect with your services? I really would love to see you kind of work on that last architectural proposal a lot more. Right? I think that'd be really interesting to really work that out, that step further, I think. And maybe, I don't know what you're going to spend your time on in the next 9 days, but I think there's some real potential there. But it needs to be worked out more in detail.
Thank you. Maybe just a few round of comments from us. Would you like to add anything, Milan?
No.
I think what didn't unfortunately come across in the presentation was the kind of deep level of architectural urban investigation and analytical approach you had in the beginning, and how that ties up with the architectural ambition. I do think that in the next period of 10 days, you really need to focus on more on the architectural implementation and the exploration of the system and how it ties to the context of Oxford Street. Because I think, most of the questions really tie to the question of Oxford Street. The fact that it's a different kind of high street, it's unlike any kind of high street in the UK, and how you contextualize the design problem. We really haven't seen kind of an image or like a future kind of, let's say, exploration of how Oxford Street will function. And that's really crucial because Oxford Street is declining at the moment, and we all know that, right? So it's very important to speculate, and when I say speculate, it's not just, out of our minds. It's based on the numbers and all the analysis that you have guys made, how these underused spaces can become useful in the future. And that's not static, that's dynamic. It's not intended to say you are not, we do not, let's say, expect you to speculate, in the next 50 years, these spaces will be used like that. No, that's not the point. Maybe in the next 5 years, we expect these spaces to be used as such and such, because these are dynamic spaces. We all know that right now, So I think you need to really emphasize the dynamic nature of how these spaces change, and the fact that, the definition of high street is changing a lot. So yeah, these are some of the things you need to speculate on. More architecturally, more kind of in terms of the material system, how this is going to act and reenact, how it is going to be articulated and activated throughout. And one of the points that Christian brought out, very important, and we have mentioned this to you, what are the kind of the changes in terms of temporality? Is it a seasonal change? Is it a daily change? Is it a monthly change? That really needs to be tied very strongly to the functional parameters and the typologies. We have brought this up, right? And we're still waiting to hear on this.
If you could, for example, like I recommended to the previous person as well, show and demonstrate some of the background or compare precedents, comparative projects. In the UK, there's one which I forget its name now. It's a small town somewhere further north near Birmingham, I think. They won a design award for it recently, so some reactivation of a high street which was effectively dead. And then they effectively took an old mall and gutted it all out and turned mainly into a park to open up towards some kind of assets that were more green assets behind that original high street, and created something completely different. So it wasn't sort of intuitively just the same functions that you have on a high street. Yeah, it was something completely new in order to create something that attracts people beyond sort of the retail, beyond sort of the tourism. Yeah, and similarly, I forget which city it is in Holland by OMA. They created something, I think it was OMA or NL Architects, create this sort of community hall, which basically doesn't sell anything, but there's all sorts of different activations across the day that are, again, synergetic with each other, and you can hardly buy anything, and is built into an old high street as well. It's almost like a market hall as well, but it has all sorts of different functions for different demographics across the day. And people are starting to think very creatively about how to reactivate town centers and high streets. That goes beyond, that's why I was a bit surprised to say, if you said there was maybe a cafe, you put more cafe there. But it's really nowadays, you think more about complementary functions. And I thought when you brought up social cohesion, that's a good idea, because people are more starting to think that high streets and retail is not just a destination, just you go shop and leave. Yeah. But it's a place where you then mingle and dwell and not shop. Yeah. And do something else that's not just the value of consuming. And there's quite a few examples in the recent years, that you can take stock from, and I suppose then understand. That's why I was also interested how that actually informs your fitness functions and the different Pareto fronts, if there is such a thing, at least in your multi-criteria optimization. Anyway, precedence.
Thank you. Thank you all. Thank you very much. And as I like to say, the last but not the least.
Good afternoon, everyone. First of all, before starting, I'm gonna reintroduce one of our members is gonna join us online. And do you want to say hello with us, Ashwin?
Hey, hi everyone. Ashwin,
this is our one of member. So, yeah. So it's going to start. So this is our master project, and our group member Aman, and one of Ashen, and me, Ijulin. With increasing global population and constant transformation, climate change and limited natural resource have become undeniable facts. In Asia, 52% of urban population growth will happen by 2035. The world urban population is also projected to increase by 25%. Now a generation cannot afford their rent, and many are forced to live in overcrowded or unsuitable conditions. This leads to the housing crisis. One successful housing program in Singapore, called the HDB, was constituted to deal with the housing crisis, and 80% of Singaporeans rely on HDB flats. Along with its efficient use of space and resource, mass housing still has several faults. That is, lack of social identity and communal space. These residential neighborhoods will not have the opportunity to adapt to the future change over time. Overall, mass housing fails to address certain aspects of housing, such as social cohesion and personal identity. This leads to the questions: what if the building can be reconfigured over time as a potential solution to the existing problem of inflexibility, and the people can participate in the design process as means to directly address their spatial needs, with the intelligent system for helping people and find out a suitable solution. That is our research project, Coalesce. Coalesce is a 400-home residential neighborhood that grows and is able to reconfigure according to the needs of the inhabitants, owners, and the surrounding urban context over 5 decades. The residential development is expected to grow, shrink, and reconfigure for over 5 decades. The different stakeholders such as architect, government, assembled workers, user, and multi-users will involve in different stages throughout the years. We propose 3 design strategies, such as sustainability, personalization, adaptability, to change each part. From assembly to space planning, usage, user needs change, home adapts, flexibility, reconfiguration, disassemble and reuse or recycle.
We present a new degree of personalization. The conventional model is linear, has a minimal user customizability, and is unable to grow or shrink in response to family size, and is replaced by a more cyclic one. Consider a user who is selecting their home voxels in a residential neighborhood. He has a certain family size and budget. The residential development's voxels would have values assigned to it based on livability factors like thermal comfort, views, and certain attractive community features within the development. A clustering algorithm presents a range of options for home locations and their cost based on voxel values. Next, the user sets parameters for the size and location of the rooms of their home. A floor planning genetic algorithm generates 3 options and presents it to the user to pick from, along with their performance scores and cost of construction. In the floor planning algorithm, the following features are optimized for: thermal comfort of living spaces, proximity of built area to core, minimal cantilever, ventilation of living space, minimal internal circulation, and improved views for living spaces. Within the user's selected plot voxels, a shape grammar-based evolutionary algorithm is run. Genes are used to select position of each room start points and the position of room rectangles. Central spaces such as living and dining rooms, internal stairs and internal corridors are generated first. The algorithm runs hundreds of iterations, learning over time, and outputs 3 good unit layouts that respond the best to its unique context in the built mass.
Our next strategy is of sustainability through the proposal of a new building system. A study of the existing building model shows that the life cycle of the material in use is not accounted for, leading to wastage and abandoned buildings. There is an expected change in spatial requirements to occur over the years, which the existing linear model doesn't accommodate, resulting in an endless succession of destruction and rebuilding. The proposed strategy is to work with a component-based system, which is designed to achieve flexibility in assembly, disassembly, and reuse, allowing for easier, faster, and robust building developments through efficiency in prefabrication and manufacturing techniques. The proposed building model explores a more viable way to think about sustainable construction, creative reuse, reconfiguration, and designing programmatically versatile buildings that last is the objective of this research. The component-based system consists of the structure, building components, components for spatial planning, services, and interior detailing. The construction process begins with the extraction of timber and prefabrication of components depending upon user customization, which is then delivered to site where the assembly takes place to form the ready home. This method allows for fast production, which is essential considering the increase in housing demand. It also allows for freedom of customization and quick assembly, which we can provide the users with. For the design of this component-based system, we applied a marching cube algorithm which uses a number of elements to create an enclosed volume. The elements form the components, and the resultant enclosed volume is the residential unit. Once the final floor plan is selected by the user, the habitable volume is extracted from it, on which the material system algorithm is applied. A final unit morphology is obtained comprising of various building components. The unit typology matrix highlights the morphological variations that can be achieved based on various floor plan clustering scenarios that emerge from user personalization. Vertical distribution of spaces within a unit is explored as a strategy to enable porosity and reduce the density of the resulting building mass. As highlighted, such a distribution creates interior space and terraces of varying scales and spatial qualities. Each unit has a unique morphology and spatial character as a result of personalization. Each user is allowed to customize the unit facade from a provided catalog depending upon their preferred utility of space, such as terrace skylights and vertical gardens. Our third and last strategy is of adaptability. There is very little consideration of the user and space relationship in the existing building design model. Through our proposal, we aim to provide an account for change in demand through adaptable spaces and space trading over the years, defining and enhancing a relationship between users and the space. A unit is formed by its structural components first, followed by the exterior panels, internal partitions, and space-making components. The user can further personalize their space by selecting through a range of partitions through a provided catalog. This catalog is designed by the architect in relation to the context, resulting in unit formations which are environmentally responsive. Users can opt for terraces, roof gardens, large openings, etc. based on their seasonal requirements. Units can be clustered onto site over the years. As and when the units are built over time, unit terraces can be activated as public spaces depending upon adjacency and edge conditions. The involved users come together and make decisions at the communal level on the nature and scale of space to be created. This approach allows for users and other stakeholders to be more involved in space making for changing social structures of society.
In Singapore, it has high density of mass housing. 80% of Singaporean relies on HDB flat. Such high density of the mass housing is why we select Singapore as a site for our project to test the workflow. The GLS program in Singapore laid out available sites for development, and we use this as the guide for site selection. We pick one of these proposals that is dairy farm. Nearby this location has 2 national parks and 2 convenient expressway and 1 international school. The area is about 1.56 ha and the estimate unit number is about 385. The population in the region is increasing over the year, and majority of the population's ages is around 15 to 64. The Singapore Building Guideline will refer to guide the setup of logic and rules for the experiments.
A tower outline is designed as a guide for users to build their homes. A GA is a design prioritizing reduction of thermal radiation for homes, achieving the target built area, achieving target public residential ratio, reducing self-view. Based on the surrounding pedestrian and public transport networks, a primary site axis is defined. Secondary axes fragment the large footprints. The building footprint is extruded upward, tapered, and scaled by the genetic algorithm. A 3-dimensional cellular automata algorithm populates the outline, and residential and public voxels are defined. At the heart of each of the 3 towers is a circulation core. The material system defines a permanent framework. Individuals build onto this predetermined framework over decades, using the flow layout algorithm and a kit of parts as infill panels. The framework and residential voxels are predetermined and therefore allow prediction of the location and magnitude of structural loading, while maintaining user freedoms by allowing them to customize infill panels. Thus, a finite element analysis can also be conducted to predict structural behavior.
This is the section of 3 towers. Public spaces is located in the center, surrounded by the living unit. And finally, let's take a minute's walk through this entire space.
Thank you, guys.
Thank
Thank
you very
you.
much.
Nice presentation. Would like to start?
I can, if you like.
Christian, did you say you could?
I could, and I can anytime.
Yeah, please do.
It's so loaded with all the algorithms that Paul and I developed in 2000, roughly. You know, that's just lovely, lovely to see such an idealistic project of throwing them all in. It's great. It has GAs, it's got shape grammars, it's got CAs, it's got clustering models, all the stuff that effectively Paul introduced to architecture between 1991 and about 2000, and some models that I then introduced with Pablo, like the marching cube algorithms and the clustering models and all that stuff. You got everything there. That's fantastic. So it's nice to see so much enthusiasm. And of course, I mean, I can imagine that if you used all of those models, that something you had to decide where to put more effort and detail into, and I think it worked quite nicely also because you limited yourself to a certain extent. You didn't go like, now we're going to do an extremely deep urban analysis or anything. We're just going to concentrate on some architectural expression, and I suppose the others will talk more about the material systems if you have probably lots of questions around that. But yeah, you used a lot of different types of algorithms. The research and the teams I work with, the people, we've done so many, research projects and PhDs and whatever about different algorithms in the past, where we used to call sort of paradigms for programs for paradigms, and programs in that sense being software at the time, or algorithms, and programs also meaning, of course, at the same time architectural programs. So there was a bit of a pun intended at the time, and so each one of those algorithms in my head has a almost very clear, or like it has exclusive domains of where they make sense, and where they don't make sense quite often. And there's some idiosyncrasies for every one of them as well, that makes it difficult to design with, or opens up real design opportunity. But I mean, I was very interested to see a marching cube algorithm again, and after a while. And as you know, there used to be rendering algorithms originally, but they're boundary creating algorithms, and they have actually equivalents as well in some other sciences, especially chemistry. And in order to be able to use a marching cube algorithm, you need to be able to think about isosurfaces and isolevels. And these isolevels producing the isosurfaces are dependent on probability density functions. So on how much you got, how much of something you have in each cube, in the marching cube, in each cube, and how you want to connect them, or what type of surface actually do you generate, a very porous or very continuous, a very large. You can create your isolevel, set your isolevel so high that no matter how much particle of any kind of density you have within the cube, it could just become one big blob. It's effectively the ultimate blob generator. And it used to be used for representing skeleton and so on, the human anatomy as well, so in biology, chemistry, etc., in different sciences. So I was wondering, clearly, if you just use any kind of isolevel, I mean, a kind of medium isolevel 0.5 or so, you get sort of these nice slanted surfaces that you use. But your isolevel needs to be set based on the probabilities density of whatever's inside the cubes. And what do you seed your cubes with is the question, right? So how did you go about this? How did you decide that that's what it's going to look like, that's how tight you're going to create your isosurface?
So to answer that question, the marching cube algorithm was run on the CA output. So what we did is we first defined a habitable space, which was a 4 by 4 meter cube. And depending on that, we ran a couple of experiments with varying, we defined the amount of surfaces that we wanted to allow for a habitable space to be created. And after those experiments, this was the final geometry or morphology that we decided, because it was giving us spaces that made most sense architecturally.
So sorry. So how did you decide then on that level? Because what type of was it a question more of what type of architecture you want to generate? Because the CA itself, if you use a voxelized CA, which I think you did in order to generate your massing, it just generally switches often. You know, the most basic model just switches a cell on and off, on or off. Yeah. So you had something that's either full or void, effectively in your case, I think, within your grid frame. But once you have basically a cube is full, it's just one input. That's what I mean. The probability density function in that cube is just 100. But depends on the whole grid. Depends on what the probability density function depends a little bit on the CA. But you can only set the ISO level then to be effectively if the thing is on or off. But then you usually would then get a quite large blobby kind of surface around just a single cell. So you must have, I don't quite know what's inside your cells, inside the voxels effectively, so you could play with the ISO level in a meaningful way. So in order to define how tight you wrap around a voxel or through a voxel, how much you cut through a voxel. Do you know what I mean?
So regarding the ISO levels, we actually did two experiments. One where the charge points were located at the center of the voxel, and the other where we took all the corner points of the voxel and used that as the charge points. So this gave us two competing morphologies for the tower, and we found that one was more porous and more suitable for Singapore for the views and the wind flows and things like that. So that's how we picked the really the charge levels or the charge point location. As well as for the floor planning, we found we found using the center point rather than the corner points allowed a more sensible architectural result for the floor planning, where the enclosed volume was not going too far beyond what the algorithm required, the floor planning algorithm required.
So did you use the Marcher cube in this case then more as an aesthetic morphology generator? Because effectively, are you saying that the CA would have actually generated the diagram of continuous units making up an apartment, for example, right? And the floor space of that, say if you had 3 cells on a horizontal plane activated next to each other into an L shape, for example, yeah. So the CA generated that. And then you use probably some genetic algorithm to optimize that over time. So the question is then, did you use the Marching cube explicitly to create the shape around the 3 activated cells?
Yes, we did.
Okay. That explains it better.
Nice presentation. I think it was really represented and all that. Thank you for that. I think I quite like the final result, the architecture that you got out of that you get different types of units. It's really interesting. The problem, of course, is it's not a very efficient system, you know. It doesn't actually create lots and lots of units. It creates probably quite luxurious units with lots of other empty space in between. But that's okay. What I do have a question with is that you do talk about these kind of public spaces high up in the sky in level 5 up to 10, 20. I'm not quite convinced by those, you know, because really there's not too many people living in these spaces. What are they really going to be used for? What are these spaces really? You kind of show them as kind of, you know, public spaces. I'm not quite convinced by that. And that brings me to my kind of last remark as well is what I am really kind of hungry for in your project is like like a final drawing, a final set of images that really, maybe it's like 3 views only, or it's a drawing that really shows what's happening. Because I think with the video, the problem with the video is you try to show so much, but it's only at a certain level. The spaces inside are empty. I don't really see, I would love to see a detail on how people really have adapted their own spaces, and they are quite unique. I don't really see that yet. I love the idea. I love how you kind of are facilitating for that, but I don't see the drawing yet. So I think I'm really waiting for that almost. Maybe in the last 9 days, that could be something to focus on, I think.
Because that's such an important point, architecturally and urbanism-wise. You've made a nice start with a video, but what if you were to capture a moment from that project? What if you were to synthesize a moment? We are in the age of videos and Instagram, TikTok, right? But what if you were to finalize that project with one I don't know, rendering or visual? How would you synthesize it? I think that would be really good. And just to add to Xavier's point, because I think it's so important, and I think we mentioned this before, the point of all these public and semi-public spaces, how are they actually being activated in the urban fabric, in the surrounding urban fabric itself? Because it doesn't mean much, when you have these public spaces all to yourself within that development, within that boundary, but it will make obviously way more sense when those spaces are activated for everyone in that region. And so how would you integrate your proposal with the rest of the urban fabric? I think that's also, in addition to what Xavier said, that's something really important to contemplate on for the next 9-10 days. And that will make these public spaces meaningful in a way.
And I would say, I think there's something interesting about this kind of what I call private public spaces. You see it in London quite often, in South Ken and all that, where you have big houses, and then in the back of it, they have like almost their own little massive garden, right? And that means it's a different type of space, right? It's used by those people. And I look at your high rise, I think like, well, okay, some of these spaces are going to be used by, 5 families. What does that mean? I don't know what that is, but I would like to understand. And in a drawing and a visual, you could actually start showing that, what that means. It's very different to the ground plane, and what Elif says about how that connects to the other urban fabric. Very different, So maybe it's 2 drawings that actually shows that.
Maybe if I can add a point of view. I think I really liked your presentation. I really have to congratulate you. There was a lot of work. I can see that you covered a lot of ground as well. You've got the, the sort of the study on modularity. You got the participatory design level, which is quite interesting. The challenge as a starting point, which is kind of obvious, but it's where you came in from. So it's really, really well explained. I think the only critique, my problem is, I think perhaps I wouldn't have gone for a tower as a final solution, as the tower inherently has got a lot of challenges, and a lot of the benefits that you could get out of your system actually are cut out when you actually are thinking of assembling this thing to that high. So maybe a more like a lower rise building would have been a lot better. But I think it would be nice also to understand in the framework that you're putting in, back to the point of the use of the building in the next 100 years, and as families evolve, there's an interesting aspect of how the modularity matches between the use of the building. So how maybe families could move around, with a system that allows them to do. So that part, I don't know if you covered, but it would be quite interesting. But yeah, so for me, it's just sort of the scale of it. It's maybe a bit too far, but just some food for thoughts.
Yeah. I think that's the point that I was trying to make about they used a lot of different models in order to concentrate on the generation of this diagram. But in order to use all of this meaningfully, you probably have to limit yourself to an architectural diagram. as well. You know, we can't resolve too much because it's just an overkill otherwise. But I agree with everybody who just spoke that what I meant also with the marching cube, understanding the ISO levels and what you did with that, with the ISO surface, is a question of how far did you push the diagram and can you translate it into architecture? Yeah? And that's where, of course, a plan drawing would come in very handily to show how you resolve the diagram from a marching cube into an actual floor plan, you know. And I don't mean the units now again. I mean, you know, if you take that through, I don't know, floor 25 and see how all of this actually connects, and are there any calls somewhere, and can people get to a call, and how are units related to each other? When you say there's user-generated conditions, are the windows all situated in such a way that they look out in such a way they don't look straight into the bathroom of the neighbor? Yeah, just little considerations of if this is at all feasible somehow, right? That's, I think, also what I agree with. And there is, of course, a project that tried to do something similar. And as Ed is just saying, the high rise may or may not be, you know, structurally especially more difficult to do that, and especially also lift shafts and all this. But the Montreal project by Louis Kahn for the Expo 1962 attempted such a modular, stacked, organic cluster of a building. And I don't know if you have in your precedents again some thinking, you know, Hermann Herzberger attempted these kind of stacked modular organic structures, Louis Kahn with his 1962 Expo building Montreal. So there are some precedents to this, how you can effectively fill in a vertical or volumetric grid and then try to connect them into communities that actually work as architecture.
All right, thank you.
Thank you. Any final comments?
I can add something. I mean, just to add and follow up what Christian said about these different tools, it would be great that you bring them all together in the final book, you know, the reasons behind each of them. I know that the CA for you guys is not a regular binary CA as far as I know. You guys went out beyond double states, and why you have done this, how then the shape grammar came to play, how the GA help you guys to solve some sort of problem. A diagram, maybe a flow chart, something that can bring them all together would be very helpful for a reader, you know? But congratulations, great project, guys.
Thank you, guys. Thank you. And thank you, everyone, for joining online and in person here. And we will see you at 6 p.m. for Christian's annual keynote lecture, everyone. So yeah, looking forward, and thank you very much again to Xavier, Eduardo, and Christian for joining us and for all your helpful feedback. And these will all be integrated with the final submissions, obviously. Thank you. Thank you again very much.
Thank you very much, everybody. I'll see you in 2 hours.
See you. Yeah. Bye-bye.
Bye-bye.